So today we're discussing probability. This again is something that, okay, you've seen before. You talked about probabilities back in middle school, right? I think so.
Yeah.
Pretty sure. And then you talked about it last year in Algebra 2. Okay? So most of these things are going to be reminders. No. All right, an experiment. Any happening where the result is going to be uncertain. Okay? Rolling a pair of dice. Choosing cards from a deck. Spinning a spinner. We don't know exactly what's going to happen, but we know some possibilities of what could happen. Okay? We say outcomes are the possible results. Okay? So an outcome of rolling a pair of dice is an adding up to 6. Our sample space, the set of all possible outcomes of the experiment. What is this number used for when we're talking about probability? It would be the denominator. Okay, the set of all possible outcomes is what we divide by. Okay, an event, any sub-collection of a sample space. You practiced finding some events yesterday in your homework. Okay, how many ways can we get a full house? That is a particular event. Okay, so when we talk about the probability, we're talking about the number of events over the number of possible outcomes. That is how we find probability. The probability of events is the number of possibilities of the event happening divided by the number of sample space. Okay. We are going to count our sample space. We can do it in a couple different ways. Okay, first thing we want to talk about is drawing a tree diagram, if it helps. Anytime we toss a coin, okay, there's a 50-50 chance. Anytime we have tossing a coin, birthing orders, or it could be boy or girl. Okay, these are examples of things that are 50-50. Drawing a tree diagram is going to be your best way of figuring out your sample space. Okay, so tossing one coin. What are your possibilities? You could get a head, you could get a tail. Not gonna land on it. Have you ever had a coin land on its side? Okay. What about tossing 2 coins? Heads, heads. Tails, tails.
Heads, tails.
Heads, tails. Tails, heads.
Ball.
Okay. How many? Tossing 1 coin, we have 2 events in our sample space. Tossing 2 coins, we have 4 events in our sample space. Now let's talk about tossing 3 coins. Okay, this could get messy if you try to remember all of the combinations, if you try to write them out. So instead we're going to draw a tree diagram. On our first roll or flip, we could have
Heads or tails?
could have heads, we could have tails. On our second flip, we could have heads or tails. See how it looks like that?
It's gonna be like a Christmas tree. Thing.
Yeah. What other kind of tree is there?
There's like a
Like
maple
one of those like
tree,
birch
tree.
I see where you're coming from.
Apple tree.
Okay, now
orange
our
tree.
third flip, we could have heads or tails. So it looks like more of a pine tree. Okay? Now, when we're talking about our sample space, okay, heads is one possibility. Okay?
Tails, tails, tails.
Okay, so let's go through and let's write all these. We have heads, heads, heads. We have heads, heads, tails. Head, head, tail. Right? Heads, tails, heads.
Heads, tails, tails.
Heads, tails.
Tail,
Tails,
heads,
head,
heads.
head.
Tail, head, tails. Tails, tails, heads. Tails, tails, tails. Bam. Probability.
Okay? So our sample space consists of how many events? 8.
Oh my gosh.
8.
It's like multiply by 2 every time. I already knew that. Let's see.
However, if I asked you for the probability of flipping exactly 2 heads, you would want this list. Because there's 3 out of the 8. Okay? Okay, so anytime you have like flipping a coin, or there's going to be problems where you're talking about like having children, whether you have a boy or a girl, and a boy or a girl, a boy or a girl, a boy or a girl, okay? Those are times where drawing a tree diagram is going to be beneficial for you. Okay? Let's talk about some vocab. You love vocab. Okay. The probability of an event will always be between and including 0 and 1. If the probability is 0, that is an impossible event. It cannot happen. The probability of rolling a 7 on a 6-sided die, that is impossible. Probability is 0. If the probability is 1, then the event is a certain event. The probability of rolling an integer when you roll a
Heads or
die.
tails. Heads. Bam. Always 100.
Always 100. Okay.
I knew that Chase gets a perfect test.
What does it mean to be a compliment? Thank you, I appreciate that.
It's like there's a 60% compliment.
Very good. Okay. If we have an event, then we say A with a little apostrophe is the complement. And it's just, if we're talking about decimals, it's going to be 1 minus the probability of A. So if we have a 0.4 chance for for event A, and we have a 0.6 chance for the complement of A. If you think in percentages, 100% minus event A. The union of two events means A or B. We will get into a little more with A or B, but if you see or, add. An empty event, there are no outcomes. Well, if you're talking about the probability, then yes, it would be. Okay. Finally, the intersect. Okay, you've seen that U, when we union together intervals, okay, that means or in probability. Upside down U, that means and in probability. And in probability means we do what?
Multiply.
What if we have disjoint events? So the probability of A and B would be empty. Or, not that, sorry, that's probability, but the number of ways it can occur would be empty. All right, let's get more into this or business. Okay? If A and B are events that overlap, okay, then when we take the probability of A or B, we have to be careful. Okay, let's go down here first. If our two events are completely separate, okay, if they don't overlap, we can simply, if we're talking about the probability of A or B, we can simply add the probability of A to the probability of B. Okay? Now, if they overlap, we have a problem. Okay? If I talk about the event, the probability of A, we're talking about this right here, right? So if I take that and I add it to the probability of B, okay? If I take it and I add it to the probability of B, what happens? Okay, well, it should be. We added this space right here twice. We added this space twice, okay? So we are going to have to subtract out the intersection. Okay? So anytime A and B can happen at the same time, we add the two probabilities together, but then we have to subtract out when they are overlapping. Right, if I'm talking about the probability of a 4 or a heart, they can happen at the same time. Now, what is it called when they do not overlap? Oh, it is right there. Perfect. Mutually exclusive. Okay? So, if they're mutually exclusive, easy breezy. Not mutually exclusive, we have to subtract out the overlap. So that is one thing that you need to ask yourself, is this mutually exclusive? Anytime you have an or probability, are my two events mutually exclusive? Okay. Yay, playing cards. Okay.
For real?
What is the probability that the card is either a heart or a face card. Okay, first of all, what is a face card?
Like king, queen, or jack.
Jack, queen, king. An ace is not a face card.
What?
It is just a high card.
That's not even a face on
Nope, there's just one of the suits. Okay? So, we're talking about or here.
That was good.
Talking about or. Are these events mutually exclusive?
No.
No, because we can have a face card that is a heart. So, first of all, okay, the probability of a heart or a face. What's the probability of getting a heart? How many hearts are there out of 52? Or, how many face cards are there out of 52?
12.
Okay, there's four of each card. We have 3 of them, so there's going to be 12. Now, out of those 12, how many are also hearts? 3 of them. There's 1 of each that is a heart, so we need to subtract 3 out of 52. Which you could reduce to 11 out of
26, I think.
yes.
So this case is okay for a card to be a card and a face.
And to subtract that.
Yeah, that's why we
One-
subtract
one
it.
or the other. It has to be one or the
Because
other.
we've counted all of the
Subtract
hearts,
that.
we counted all of the faces, but there are 3 face cards that are hearts.
It's because you like counted those cards twice. So you subtracted one for the
Right. If we subtract it out twice, then we're not counting those at all. Right. So, I'll go back to my picture. We had all of our hearts that we counted.
Oh.
I understand that.
I see.
The
No.
question of the problem. Is it okay in like the cards that we want for it to be a heart and a face?
Yes.
Okay, that
It was the wording.
yeah.
And the problem actually for probability of drawing a card is either heart or face.
Not both.
Not heart and face.
Yeah, but if you draw a heart and a face card, it's
But is it a heart or a face?
Yeah.
Yeah.
Say and or.
we can have to
Or is it implied that it could be either one of them? Right. Okay. What about the probability that the card is a heart or a club?
That's pretty good.
Are these mutually exclusive events?
Yes.
Yes.
Yes, they're not overlapping. So the probability of a heart or a club.
That's beautiful.
What's the probability of a heart?
13 out of 52.
There's 13 hearts out of 52. Or
50%.
a club. If they're mutually exclusive, add the 2 probabilities together. If they're not mutually exclusive, subtract out the overlap. Independent events. Two events, they're not going to affect each other. Who can give me an example of an independent event? Or 2 independent events? Flipping a coin.
Rolling a dice.
Okay. flipping a coin and then rolling a die, is flipping the coin going to have an effect on rolling the die?
Probably not.
No. Okay. Non-independent event. Drawing a card from a deck and not putting it back is going to have an effect on me drawing the next card because there's less cards in the deck. Okay? So independent events, they're not going to affect each other. So if we are independent, if we want to find the probability of A and B, then we can simply multiply the two together. Then, if we have dependent events, then the probability of B has to be adjusted. The probability of B given that A already happened. So, give me a minute. A sales rep makes a sale at approximately 1/3 of all calls. If on a given day the rep contacts 5 potential clients, what is the probability that a sale will be made with each of the 5 contacts? Okay? Does her calling Aaron affect the outcome of her calling Carl? No. Each time she calls, she has a 1 out of 3 chance. So the first person she calls, she has a 1 out of 3 chance. The second person she calls, she has a 1 out of 3 chance. The third person, the fourth person, the fifth person.
Yeah, what if she accidentally goes 4.003?
What? She will not make that mistake.
We don't know her yet.
Maybe she'll sell.
Okay? Now, okay, Aaron was asking about dependent events. Okay? Choosing 2 kings without replacement. Okay? So what's the probability of me drawing 1 king?
1 out of 52. No,
It's 4 out of
4 out of 52.
4 out of 52.
What?
Now, I am not replacing it, so I can't say times 4 out of 52. How many kings are left?
Yeah.
How many cards are left? 51. So those events are dependent of each other. So we have to adjust the next probability.
004,437.
Thank you.
What if you didn't draw a king first draw?
Okay, last set of examples. Study problems, 10 will be a part of the test. You guys do this tomorrow, huh?
50%.
A student knows how to solve 15 of them. First of all, let's talk about our sample size. What is our sample size?
I don't remember what.
20 study problems, 10 will be on the test. We have 20 problems, only 10 will be on the test.
I don't know.
We have 20 problems.
30
where
problems.
The teacher will only choose 10 of them for the test.
Oh, no.
Right? Well, if I choose... No. Because if I'm choosing 5 people from this class, I'm not picking the same person 5 times. No, order does not matter on the exam. Now, if it said unique tests, that would be different. Okay, that would be a permutation. Now, what's the probability that this student will answer all 10 questions correctly? Well, be able to answer them on the exam. He only knows how many? 15. So, what's our numerator? Our denominator, we have 20 questions and we picked 10. They know 15 questions and they're gonna know 10. There we go. They know 15 and 10 of them will be on the test that they know. What's this probability?
Going up.
So even though he knows 75% of the material, there is only a 1.6% chance he's going to get 100. At least 9 questions. What does at least mean? He could get 9 correct, or he could get 9 on the test he knows, or he could get 10 on the test that he knows. Okay, we already know what 10 is, right? 15, choose 10, over 20, choose 10, or he could get 9 correct. 15 choose 9, but that only accounts for 9 problems. There's going to be 10 questions on the test. 7 choose 1. How many questions does he not know? He does not know 5, and 1 of those questions will be on the test. He knows 15. Out of those 15, 9 will be on there, but it's a 10-question test. So out of the 5 he doesn't know, 1 of those will be on there to make up those 10 questions. .5% chance of getting an A. Is that a good study strategy?
Yes.
Not if you want an A.
I'm bad at sleep.
Any more questions on this example? There you go.